All right, let's look at the finding the domain of f over g. All right, so let's look at this example. F of x is equal to square root of 3 minus x, and the g of x is equal to square root of x squared minus 1. All right, and we want to find the domain of f over g. All right. First, we need to find the domain of each, so separately. So we have domain of f, right? So how do you find that, right? So we have the square root, so we have to make sure that stuff inside the square root is non-negative, right? So we have 3 minus x is greater than or equal to 0, right? Then we can just isolate x by simply adding x to both sides. So negative x cancel out, so it's a 3 is greater than equal to 0 plus x is going to be just x. So you can see that the x is less than equal to 3, right? So which means that it's going to start from negative infinity and all the way to positive 3, right? Then we want to include that 3, right, because of the equality. All right, how about domain of g? So domain of g of x, right, it's the same idea. So we're going to just look at the stuff inside the square root has to be non-negative, right? So we need to solve this. X squared minus 1 is greater than or equal to 0. Right? First, I'm going to solve the equality, so we're going to turn this into x squared minus 1 equal 0. Right? Then if you factor out x squared plus 1, we can turn it into quantity x plus 1 times quantity x minus 1. Right? So is equal to 0. Which means that when x is equal to positive 1 or negative 1 plus or minus 1. Right? So then I'm going to just use a number line. So draw a number line. And I'm going to put a tick marks for negative 1 and also positive 1. And what we want to do is we want to look at the sign of this expression, x squared minus 1, on these 3 intervals, right? So anything less than negative 1, I'm going to try x equals negative 2, right? So if you plug in negative 2 squared would be 4, minus 1 is 3, so it's positive, right? So any number, any sample number between negative 1 and the positive 1, so I'll try 0. Right, 0 squared minus 1 is negative. Right? Then we can try anything bigger than 1, so I'll try positive 2. 2 squared 4 minus 1 is positive. Right? So we get that. So in order to solve this inequality, we want either positive or 0. So 0 is right here. 0 is right here. And also expression 0 when it's positive or negative. Right? So we want to include that. And also anything below negative 1 and anything above positive 1. Right? So we know that this is going to be, right? So we're going to have start from negative infinity. And you can see that it's positive all the way to negative 1. Right? And also, so I have to use use a union to combine that. And starting from positive 1, and you can go all the way to infinity. All right. Then, in order to find the domain of f over g, first you have to make sure that it has to be in the domain of f. At the same time, intersection, the domain of g, right? All right, so here's the one more complication when you have a fraction. So we have to make sure that the denominator, in this case g of x, is not equal to 0. So we have to also make sure that we have to also pick the x such that the g of x denominator is not equal to 0. All right, so we have to satisfy all three conditions. All right, so let's do a number line so that we can determine. So what I'm gonna do is here. All right, so I'm going to represent the so domain of f is less than or equal to 3, right? So I'm gonna put 3 right here. All right, and the less than, so I'm going to use a green for f. So you have f is starting from here, right, including 3. So I'm going to, let's see, I'm going to put a circle there. And I'm going to take anything below or equal to 3, right? So I'm going to just shade it, right? So we like to keep that for now. All right, at the same time, it has to be inside the domain of g. All right, domain of g is less than or equal to -1 or greater than or equal to +1. So I'm going to put 1 is probably around here and a -1 around here. All right, this one, I'm going to use the maybe a blue, right, light blue. All right, so it's going to going up from here and up, all right, and from -1 and below. All right, so we're shading this way. All right. All right, last thing would be, all right, we have to make sure that g of x is not equal to 0. All right, we know that the g of x is 0 when x is equal to +1 or -1. All right, so we can keep anything outside of that. So let's see, I'm going to try to use a different color. So I'm going to use a purple. All right, so anything, so here, -1 we have to exclude it, and we have to exclude +1, right? Anywhere outside of that is okay. All right, so here, all right? So when you combine that, where are the intervals where it's shaded by 3 different colors? All right, so you can see that here, down here, starting from -infinity. All right, so it's shaded by 3 different colors all the way to -1, but not including -1. So we have to put the parentheses, right? And here it's not shaded by blue, light blue, so it's not including. But starting from 1, so union. So we're going to start from 1, but we have to use the left parenthesis because 1 is not included, all the way to 3, including 3, is shaded 3 times. Right? So therefore, the domain of f over g is an interval from -infinity to -1, not including -1, union from 1 to 3, not including 1, including 3. Right? So this is the domain of f of g. Right? That's it. I hope that this was clear.